Okay, so here we're going to talk about graphing, all right, and um, what we need to be able to do for graphing. So this one will just be graphing basics, and then the next video I will do will be going from one graph to another to another. All right, so if we take a look here, and I'm going to change colors here. Let's go to, let's use a nice green. Let's use that one. All right, so let's say I have a graph that looks something like this. All right, now if we were taking a look here, right, and let's say I have another graph, and let's do the same shape, same basic shape there on the V versus T graph. So if we're taking a look here, on this D versus T graph, they're all straight lines, so that indicates to us constant velocity in each case. In the first section here, we are moving away from the origin. In the second section here, we are not moving because that portion, it is flat. And then here, we are moving towards the origin, all at a constant velocity. Now, if I wanted to know the velocity at any given point, I could absolutely do that. All I would have to do is calculate the slope at any given point. The reason for this is the slope on this graph would be a change in y over a change in x. And on this graph, a change in y would be a displacement over the amount of time to change. Well, if you look at your equation sheet, that's a velocity. So a slope on a D versus T graph will give us a velocity. If we take a look at a V versus T graph in a similar way, now in this one, we're moving away from the detector the entire time. We're moving away from the origin the entire time. The reason we know that is we have a positive velocity values the entire time, right? We're never at rest here. So during this part, we are speeding up. During the flat part, our velocity is not increasing, it's not changing, so we have constant velocity there. And then here, our velocity is just going down, so that means we're just slowing down, but we are still moving away from the origin because these values here are still positive. And yet again, we could know exactly the rate of change of that velocity if we calculate the slope. So if we calculated the slope here on this graph, a slope would be a change in y over a change in x, which would be a change in velocity over a change in time, which, if you look at the equation sheet, is an acceleration. So the slope of a D versus T graph gives you a velocity. The slope of a V versus T graph gives you an acceleration.